Hi everyone, today we're going to study transpose of a matrix. If capital A be an M by N matrix, then the matrix obtained by interchanging the rows and columns of capital A is called the transpose of A. Transpose of the matrix A is denoted by A apostrophe or A with exponent capital T or A with exponent small t. In other words, if capital A is the matrix M by N, then A transpose is equal to the matrix N by M. Example, if matrix A has these elements 3, 1, -5, 12, 7, 6 respectively, we can see that this is a 2 by 3 matrix. Then the A transpose is equal to this matrix. So you see here, the first row of matrix A is equal to the first column of A transpose. Also, the second row of matrix A becomes the second column of the A transpose. We observe also that the A transpose now is 3 by 2 matrix. Let's go to symmetric matrix. A square matrix A is said to be symmetric if A transpose is equal to A. That is, the matrix with element A sub ij is equal to the matrix with element A sub ji for all possible values of I and j. Example, matrix A with elements 3, 5, 5, -7. This is a 2 by 2 matrix. This is a symmetric matrix because the A transpose is equal to this matrix. We can observe that the first row here becomes the first column of A transpose. Also, the second row of the matrix A becomes the second column of A transpose. We note that this is also a 2 by 2 matrix. Comparing the two, this A transpose is also equal to that matrix A. Therefore, this matrix A is symmetric. Let's go now to skew symmetric matrix. A square matrix A is said to be skew symmetric if A transpose is equal to the negative of the matrix A. That is, the element A sub ji is equal to negative A sub ij for all possible values of I and j. Note that all the diagonal elements of a skew symmetric matrix are 0. Example, matrix A with elements 0, 5, -5, 0. We can see here that this is a 2 by 2 matrix. Also, the elements in the main diagonal are all 0. This is a skew symmetric matrix because the A transpose is equal to this matrix. The first row of matrix A is the first column of the A transpose. The second row of matrix A is equal to the second column of A transpose. We can see that the A transpose is also a 2 by 2 matrix. If we compare this A transpose with the matrix A, this A transpose is equal to the negative of the matrix A. Therefore, this matrix A is skew symmetric. Let us study orthogonal matrix. A square matrix is orthogonal if A times A transpose equals I, or the identity matrix. Example, if matrix A equals with the elements sin x, cosine x, negative cosine x, sin x respectively, then verify that A times A transpose is equal to capital I. For our solution, first we will write the A transpose. The elements now are sin x, negative cosine x, sin x respectively. Then we're going to multiply A by A transpose. So we will write our matrix blank here. We will do and start the row column multiplication. So the first row multiplied by the first column. So we have here sin x times sin x plus the cosine x times cosine x. For the element here, we have sin x times negative cosine x plus cosine x times sin x. For the element below, we have now this negative cosine x times sin x plus sin x times cosine x. Then the last will be negative cosine x times negative cosine x plus sin x times sin x. From here we can simplify the sin x times sin x into sin square x. For this, we can write cosine square x. We have here also the negative cosine x times negative cosine x. We write here cosine square x. And for this, we have the sin square x. For sin square x plus cosine square x, we can apply the rule of trigonometry identities. Also, we can write the same identity idea for this expression. In here, we are going to use the simple algebra. The sin x times negative cosine x will be negative sin x cosine x plus this is sin x cosine x. Later, if we add, this will be 0. Down here will be negative cosine x times sin x is negative sin x cosine x plus this sin x times cosine x will be 0. The product A times A transpose will be equal to, this is equal to 1, this would be 0, this is also 0, and this is 1. We can see here that the resulting matrix is equal to the identity matrix of order 2. Therefore, the matrix A here is orthogonal. Here are the properties of transpose of matrix. For any matrices A and B of suitable orders, and K is a scalar. First property, the transpose of A transpose is equal to A. Second, the transpose of the sum A plus B is equal to A transpose plus B transpose. Third, the transpose of the product A times B is equal to B transpose times A transpose. Fourth, the transpose of the product K times A is equal to K times A transpose. Fifth, A plus A transpose is always symmetric. The last, A minus A transpose is skew symmetric. I hope you learned something from this video. See you again next time.